All right, I grabbed a new light. This seems to help with the blurriness. All right, so I haven't looked at this one yet, so let's look. Number 3. The function f is defined on a closed interval. The graph of f consists of 3 line segments and is shown in the figure above. Okay, so this is f. Let g, we don't know what it looks like, right, be the function defined here. This is a fundamental theorem of calculus question. We have no idea what g of x looks like right now. Okay, find g of 3. This needs to be an absolute slam dunk, right? To find g of 3, I'm going to plug in 3 right here. So I'm really looking for the area under the curve between -3 and 3. So I go up here and I'm like, joop, joop, joop. And this is just like a geometry problem, basically. It's like figure out the areas. So this area here looks like it's worth, I don't know, what, 2 times 2 is 4, so that's worth 2. Then this entire triangle is worth, I don't know, 1, 2, 3, 4, 5. 1, 2, 3, 4, 20. So this is worth 10, I guess. And this one here, we lose space, but it's 2 by 4, which is 8. Chop that in half, it's 4. So pick up 12, lose 4, you end up with 8. So g of 3 equals 8. Okay, A is done. Let's look at B. On what open intervals contained in this thing is the graph of g both increasing and concave down? Fantastic question. Okay, so g, we don't know what it looks like. We want to know when is it increasing and concave down. So let's deal with the increasing part of it first. Okay, so when is g increasing? Well, fundamental theorem of calculus tells us this thing here, that's the derivative of g. Okay, this picture, okay? So think to your layer cake, right? G is going to be increasing when its derivative is positive, okay? Look up here, this is the derivative. That means g of x is going to be increasing, it looks to me, from, let's say, -5 to 3, and then from 3 to -3 rather, -3 to 2. Do you see? And then like right here, it's not increasing or decreasing. Okay, whatever. When is it going to be concave down? G again. Well, that's when the second derivative is negative. Okay, second derivative is going to be the derivative of this. So when is the derivative of this negative? Okay, well that's when this thing is decreasing. So that's from -5 to -3. It's decreasing, right? And it's decreasing from 0 to 4. Okay, so then I need to see where the, oh geez, yeah, okay. From -5 to -3, and then from 0 to 4. That's when this thing is decreasing. Okay, so now I need to see where they overlap. Looks like from -5 to -3, concave down and increasing. And then maybe have a look at these things from 0 to 2. So the intervals are going to be from -5 to -3, and from 0, you can't see this. From -5 to -3, and from 0 to 2. Okay, that's it. All right, C might be trickier. The function h, again, we don't know what it is. It's defined by this. Find h prime of 3. Okay, this is literally h of x. Okay, so I have to go and I have to find the derivative. Okay, this is a quotient rule situation. All right, derivative of the top, I'm going to take it down here. It's g prime of x times the plain old bottom is 5x minus the plain old top is g of x times the derivative of the bottom is 5. Excuse me, all over this thing's squared, so that's 25x squared, okay? That's literally the derivative, okay? That's h prime of x, the derivative of h, okay? Now, they want h prime of 3, so all I'm gonna do is stick 3 in everywhere. So it's g prime of 3 times 5 times 3, which is 15, minus g of 3 times 5, all over. I'm gonna stick in 3 here, 9 times 25 is 225, okay? So now think about it. G prime of 3, what is that worth? Well, g prime of 3, up here, this is the derivative of g, okay? So g prime of 3 is just whatever this is worth when x is 3. And if you do a little bit of math, hang on a second, it's worth -2. So g prime of 3 is literally -2. So this turns into -2 times 15 minus g of 3. Well, g of 3, we already got that up here, it's 8, right? So minus 8 times 5 all over 225. Now it's just arithmetic. -2 times 15 is -30, minus 40 all over 225. I don't know, who cares? Finish it off however you want. -70 over 225, simplify it. I don't know, factor out of 5. -14 over 45. Is that it? Okay, that should be it. All right, let's look at D, see if I can do this all in one fell swoop. D, the function p, or so we have a new function. All right, this time it's p, this is how it's defined. Ooh, tricky. Okay, so p of x is f of x squared minus x. Find the slope of the line tangent to the graph of p at the point where x equals -1. Okay, slope of a tangent line, that's the derivative. Okay, so I want p prime of x, I want the derivative of this thing. Okay, so the derivative of this thing, okay, I don't know how to like explain this in a good way other than just being like, this is what it is. Okay, so if we want the derivative, okay, it's going to be f prime of x squared minus x. And all I can say is, what's the inside function? You have to multiply it, chain rule situation, by the derivative of the inside, which is that. So times 2x minus 1. Okay, so this is literally the derivative. Okay, now I want the slope of the tangent line when x is -1. So I'm going to plug in -1. So I'm going to get f prime, plug in -1, you get 1 minus -1. Times if you plug in -1 here, you get -3. So it's f prime of 2 times -3. Now f prime of 2, well, oh, this is a good question. Here's f. So f prime is the derivative of this. So f prime of 2 is what's the derivative right here? Well, that's the slope there, the slope of the tangent line, which is just the slope of this line here. And it looks as if the slope here is -2. I hope it is. That's just some sort of quick look at it. So f prime of 2 is worth -2. Aha, f prime of 2 is worth -2. -2 times -3 is 6. Boom, done. That's it.